Hello everyone, welcome to a 5 minutes CS talk. The quantum computing is really mysterious and popular these days. There are all kinds of articles and videos describing the quantum computing online. In this video, we will describe necessary things you should know before writing your first quantum computing program. Instead of discussing detailed knowledge, I try to summarize and classify some good references I know and try to provide a big picture for the quantum computing. It is a kind of entry to better understand the quantum world. Ideally, I hope that I could provide some ideas for this topic within several minutes and to help you move forward to the next step by yourself based on the knowledge graph described in this video. When we discuss about the quantum computing, one important thing is a view of the context of our discussion. For the first step, we need to know that quantum computing can be viewed from perspective of math, physics, or computer science. So briefly speaking, at the beginning of the quantum story, some physicists observed some interesting phenomena based on the quantum, and they found that it is hard to describe those systems based on existing mathematical tools. So they developed a new mathematical system to describe the evolving of the quantum system. It is called the quantum information theory, and after that, some computer scientists found that it is potential to use those phenomena to accelerate the existing algorithms. So what is the gap here from the scratch to the first quantum computing program? We need some necessary knowledge from those different levels, from physics level, math view, and the computer science. For this part, I will go through the necessary concepts quickly instead of diving into details. I believe you could find lots of materials that introduce those concepts online. The first concepts are bit and qubit. For most of the people, it might be the most interesting part about the quantum computing. Those concepts come from the information theory. In the classical information theory, we use bit to represent a basic unit of the information. For the quantum world, we use the quantum bit, which is a qubit. And the next important concept is to understand how to express the bit and the qubit from the physical level. There is a long history to find a suitable device to carry the classical bit, and currently we use the transistors to carry the bit in the classical computer. For the qubit, we are still at the early age. There are some existing systems of existing quantum computers that use superconducting or ion trap to carry the qubit, and you may find more interesting articles online. Another important thing is to figure out how to express bit and qubit in math. It only makes sense if we can manipulate multiple bits or qubits at the same time to generate the algorithm. For the classical bit, basically it is a fixed point in 2 to n space, but for the quantum bit, it is a mixture of the base vector in 2 to n space. And there are another concept called amplitude. So you could search it online to get more information here. The next step is to understand the quantum gate. If we know how to express one qubit and several qubits, we may also want to figure out how to manipulate these qubits and how the system evolves with the time. From the perspective of the computer science, we use quantum gate to express it. And from the physical perspective, there are some related concepts such as a Hamiltonian metric, wave function, or measurement. And if we understand those concepts intuitively, if we want to make our system evolve with the time, we need to apply external influence to those systems. which can be expressed by Hamiltonian matrix, and we could use wave function to describe in particular time what is the status of our system, and the measurement means that we could get the particular state of our system by the measurement, because for the quantum system we don't know what is its actual status if we don't measure it, and when we start to measure it, it will collapse into a particular state, and it becomes more tough from the mathematical view because you need to understand some advanced knowledge for the linear algebra. In order to define those different concepts in physics, we may need to understand the complex number, the unitary matrix, a Hermitian matrix, and so on. If you have figured out those concepts discussed just now, it might be a suitable time to move to the first quantum program. We could use several quantum gates to manipulate multiple qubits to do some quantum algorithms and get expected results. And more tasks come to the domain of the computer science, such as how to program, how to debug, and how to program a fault-tolerant program, and so on. For computer science, the main task for this step may be how to combine classical algorithm and quantum algorithm to see if there are further improvements, if we can use a quantum algorithm somewhere. And of course, the depth understanding of physics is beneficial to better understand some algorithms such as quantum annealing. For perspective of computer engineering, the main task is to see if we can make a real quantum computer that can manipulate large number of qubits with a small error. For math view, since there are tight relationship between the algorithm and the math, some knowledge such as symmetry or group theory may provide a different view to understand the algorithm. Here are some really good references for you to move forward to your first quantum program. For the math view, here are some really good YouTube accounts, and they visualize some fundamental concepts and help you to understand those concepts by intuitive way. For the perspective of the physics, for this YouTube account, this guy provides a series of lectures. There are 16 lectures about the quantum theory, and this professor comes from the University of California, Berkeley, and this is a really good lectures, and this professor described some concepts and really clearly. And for the perspective of the computer science, for this Kirk program, you could just create your first quantum program by dragging those blocks to a particular position, and you could create several qubits and manipulate them by different quantum gates. Another framework is provided by Google. It is called Cirq. You could use Python programming to write a quantum program that can run on your computer or some large machines. It is a simulator to do the quantum computing, and just try them and enjoy it. So that's all for today. Thanks for watching, and see you next time.